Hi, Christian. Welcome back. We realized we made a mistake last time and that I had the camera too high. So this is actually the third time we're getting to light all kinds of matches. Carlos is trying to burn Jess's hair. You are missing all kinds of crazy, pyromaniac fun here today. We hope you're feeling better, and let's get to our practice problem. On combustion. Okay. So much fun when you're not here. Go figure. Okay, no more matches. No more combustion. Carbon dioxide and water, right? Okay. So let's walk through one of these practice problems. These are the problems, guys, that I said would take you a whole page to do. These are the problems that if you are not organized and you do not label your work and try to just hurry up and write down numbers, you're going to get wrong because there will be numbers flying everywhere, okay? So we're going to walk through our steps with this question. We have a compound. We know it contains only C, H, and O. So we will give it the generic formula CaHbOc. Combustion of 10.68 milligrams. All right, combustion means we're reacting with oxygen. That tells us it's combustion. You should write that. It yields 16.01 milligrams of carbon dioxide and 4.37 milligrams of water. And they give us the molar mass of the compound. Again, why would they do that? So that later we can go back and find the molecular formula, just like last time. What are the empirical and molecular formulas of this compound? Okay, so what was step one, Tony? Will you reread it for us, please? Okay, we wrote the generic equation. So, Tony, what is step two?
Convert mass of CO2 to moles of CO2 and moles of C.
Okay, so we're going to deal with the CO2 first. We're going to convert this to moles of CO2, then moles of C, and then eventually grams of C. You can kind of combine these two steps. So here we go. We have 16.01 milligrams of CO2. You should know how to do all these steps. We don't work with milligrams, we work with grams. So first thing we have to do is to convert it to grams. 1 milligram is 0.001 grams. If that's something you want to do before you start your unit conversion here, you could just do it right over here, right? That's what that number is in grams. And that's what that number is in milligrams, or grams. You could do it there, but I'll just keep going. Okay. So that would give us our grams of CO2, which we then have to convert to moles of CO2. .01 grams, that's the formula mass, if you don't know where I'm getting it from. And then we convert that to moles of C. Every 1 mole of CO2 contains 1 mole of C. And that'll give us our first really, really, really important number. Carlos, what's the first really, really, really important number?
3.64 times 10⁻⁴.
Is that the whole big long thing? Don't round it for me.
3.63780958.
Times 10 to the negative fourth?
Yeah.
3 point, go.
6378095.
Times 10 to the negative fourth. Uh-oh. Moles of C. That says times 10 to the negative fourth there, guys. Moles of C. I did just move it, I swear. Okay?
Oh, so we combine steps 2 and 3?
What was step 2? Write the equation.
No, step 2 was convert the mass of CO2 to moles, and then the moles of C. Oh, no.
No, we didn't do grams yet, so that was just step 2, okay? But this is a really important number right here. You might want to put a box around it. You need the moles of carbon. Remember, the whole goal is to get the moles of C, H, and O. Well, you've got now the moles of C. Oh, when I want to move that stinking thing, I can't. There's the moles of C. We got it, okay? Right? Okay, got it. Now, if the only reason we get the grams of C is so that we can get the grams of O, right? So I just do it now because I'm on C. I might as well just keep going and get the grams of C. So now we're going to take step 3, take our moles of C. It's already in our calculator, right? 0.36378, yada, 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 times 10 to the negative 4th moles of C, and convert that to grams of C. 1 mole of C is 12.01 grams. And if we do that, what is the mass that we get? Is Carlos the only one plugging this into his calculator? Everybody should be plugging it into your calculator. I just did yada, 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 because I figured you already had the number in. Bryce, what'd you get? 4.369. Oh, that's not what they got.
Yeah, I put it to the 10 to the negative 30 though. I put it.
Oh, okay, he put it in scientific notation. So it is what he got. It is what you got. You got the same thing. He just gave it to me in scientific notation. You're not. So what was it, Bryce? 4.369093
times 10 to the negative
Okay.
to the third. Not negative.
It should be negative.
Oh, then yeah.
Is it negative or not negative?
Yeah, it's
Okay. Right? 0.0043690093. Yes? Okay. All right, steps 1, 2, and 3 are done. What's step 4?
convert mass of H2O to moles.
Okay, convert the mass of H2O to moles. Jess, what was our mass of H2O?
4.37.
4.37 milligrams of H2O. So we're going to convert that to grams first. And then convert that to moles. 1 mole of H2O is 18.02 grams. That'll give us our moles of H2O, but we don't want moles of H2O, we want moles of H. According to the equation, for every 1 mole of H2O, there are, right, Leah? 2 moles of H. 2 moles of H. So let's go ahead and plug that one into our calculator and get our moles of H. Welcome back. What'd you get this time, Will?
4.850166482.
Good. Times 10 to the negative 4th moles of H. There's our second element's number of moles, right? The whole goal is get moles of C, H, and O. We've got C and H. So everything else that we do is to get the moles of O. What's step 5, Tori?
Convert moles of H to grams of H.
All right, no worries. We got this. Now, notice what I do just to save time writing. I do like 4.85 yada, yada, yada times 10 to the negative 4th moles of H. I'm going to plug in the whole number. But I'm just, to write it right now is kind of silly. 1 mole of H is 1.101 grams. So multiply that by 1.01, and you should get 4.898668147 times 10 to the negative 4th grams of H. calculator and just write it down. So on your paper right now, you should have your moles of C, your grams of C, your moles of H, your grams of H, right? Okay, what is step 5, I think we're on, Jenna?
6.
6, Jenna?
Oh, we're on 6, I thought we were 5. 6, you have to find the, how many moles of O we have. So we have to,
Then we're on 5. We're not finding moles of O. So what does step 5 say?
We just did.
step 5 says convert moles of each.
Okay, we did that. What's step 6 say?
Obtain mass of O.
Okay, so not moles of O,
Mass
mass of O. So to get the mass of O, we take the grams of the compound and we subtract from it the sum of the mass of C and the mass of H. So I have to go back to my stinking data, get the grams of my compound. Uh-oh, they gave me milligrams. So let's just convert it right now to grams. 0.01068, right? There it is, okay? You should know how to do that. That should not be the issue. So it's 0.01068 grams of your compound minus the mass of carbon. Where did we write that? Oh my gosh, look at this paper. There it is, 4.369009. Yada, yada, yada. Times 10 to the, what was it, negative third? And then your mass of hydrogen, which was 4 point, you know what? I'm going to cheat because I can. Okay. Ah, the wonders of the smartboard. So we're going to add our grams of carbon and our grams of hydrogen together and subtract them from the mass of our compound. And that will give us our grams of oxygen. I got to go back up here. So you guys do your thing. I'm going to do my thing. My calculation. I got to get that on paper. Oh, man, we're going to run out of time for Christian. 369093 to the EE negative 3 plus oh, I took it. I'm like, where'd that number go? 4.898668147 to the EE negative 4. I got, hopefully y'all got the same thing, 0.01194112239. No? Ouch. All right, let me try again. 0.0160. I put in the wrong mass. 08. Jeez. Let's pause this. So, our mass of oxygen, if we actually add all the numbers and enter the numbers correctly, just modeling how easy it is to make a mistake, is 0.058213226 grams of O. We don't need grams of O, we need moles of O. So now we will convert that to moles by dividing by the formula mass. And that is 3.63823265696 times 10 to the negative 4th moles of O. So all we did was rewrite all our moles of everybody that we had. Now that we have those, we divide everybody by the smallest. So what is the smallest? Okay, take your pick. Oh, carbon, right? So divide everybody by the moles of carbon. I'm not rewriting that number. That's crazy. I'm just going to write on my paper that I'm dividing everybody by the moles of carbon. And that's obviously going to give me 1 here. I divided everybody by my moles of carbon, and I got 1 up here, 1.33 here, and 1 here. Which means right now, my impurity